In this third lesson on ellipses, we're going to start with how to use technology to graph an ellipse. And we're used to seeing ellipses in standard form, but as you can see that's not the way that we're used to putting equations into the calculator. So we need to rearrange the equation so that it's in the form y equals, so we can put it into the graphic calculators. So if I start with this equation, I want to isolate the y variable, so I'll subtract this x term from both sides of the equations to start with. So I have y squared over 9 equals 1 minus x squared over 36. And multiply both sides by 9, so that y squared is 9 times 1 minus x squared over 36. Now I could multiply that through if I wanted, but really why not let the calculator do the work. So now I'm going to take the square root of both sides. So y is equal to positive and negative root of all of this stuff. 9 times 1 minus x squared over 36. The square root of 9 is 3, so I could simplify that a little bit and say y equals plus or minus 3 times the root of 1 minus x squared over 36. So now we need to look at how do we enter that in the calculator, because there's no button that says plus minus. We have to say that we'll graph it in 2 steps. Because an ellipse, if you think about it, an ellipse is not a function, but we can think of it as 2 different functions. So we can think of one as y is the positive root of 3 times the square root of 1 minus x squared over 36, and y is negative 3 times the square root of 1 minus x squared over 36. So I'm going to bring up the calculator here so that we can see how to put that in. Okay, so if I turn the calculator on, okay, so I got y equals, y1 equals, so I'll do 3 times the square root, and I want all of that in brackets, so 1 minus x squared divided by 36, and now I'll close the bracket for the square roots. And then what I'll do is just skip down to the second y2 equals, and I'll put in the negative value, so negative 3 times the square root of 1 minus x squared divided by 36. I'll close that bracket and I'll press zoom, and I want zoom square, so that's the 5th one there. So there's the positive 3 and there's the negative part. So there's the ellipse graphed on the graphing calculator. So we rearrange it into y equals form, recognizing when we take the square root we have a positive root and a negative root, and entering that in 2 different stages, and press zoom square, because what that does is it gives the same length for each x unit as it does for each y unit. Okay, as we move on, we're going to look at some applications for ellipses, and there's really interesting stuff in the textbook about elliptical orbits of the planets, about elliptical domes, and how ellipses are used in treating kidney stones. So if you get a chance, read some of those, pages 907 and 908, and we're going to look at another application here of seeing if a truck will fit under an elliptical bridge. Okay, so we've got a truck that's 14 feet high, 10 feet wide, and we want to know if it'll fit under a semi-elliptical bridge that is 20 feet high and 50 feet wide without having to go into the other lane. Okay, so what we do for a problem like that is we think about that bridge as being half of an ellipse. Okay, its height is 20 feet in the middle. It's 50 feet across, And if you think about graphing that on the Cartesian plane, you could think of that being centered on the Cartesian plane where it looks like this. So if it's 50 feet wide, this point is actually going to be 25, 0. And if it's 20 feet high, that point is going to be 0, 20. So that gives us our A and B values for the equation of this ellipse. So we end up with x squared over 25 squared plus y squared over 20 squared equals 1. Or we could write that. We can just expand those two, multiply those two values out, and we'll have x squared over 625 plus y squared over 400 equals 1. Okay, so now to see if that truck is going to hit the edges as it goes under that bridge. So if you think about that truck uh, going under the bridge, it's 14 feet high and 10 feet wide. So we want to see if when we go 10 feet across, are we more than 14 feet high? Okay, so in other words, when x is 10, we want to make sure that y is at least 14. So we just substitute 10 in for the x. So we'll have 10 squared over 625 plus y squared over 400 equals 1. So that's 100 over 625. So we'll have y squared is going to be 400 times 1 minus 100 over 625. And then we'll take the square root of both of those sides, and we end up with y being approximately equal to 18.3, which is in feet for measurements. So you can see that, yes, there is clearance for the truck. Okay, some of the questions in the book talk about a one-lane road. So when you're doing those, keep in mind then that you've got your ellipse centered on the XY axis, but because it's a one-way street, you're actually centering your vehicle in there. So you only need to know half the width of your vehicle when you check the point to see if the height is there. Okay, and that's the end of this little mini lesson on ellipses.